What is up, folks? This is Mr. Walker here, coming to you with our next lesson. Folks, we are going to be digging in to segments and angles and how to measure them. So let's get started. All right, we're talking about measuring segments. We're talking about line segments, obviously. And we've used them before, but we're going to definitely use them now. And we're talking about rulers. Now, the idea with rulers for this. Not every line that we're going to see is going to actually be drawn to scale. The ruler is just going to be more or less used like a number line for us. So let's get into our first definition, the ruler postulate. So the points on a line can be paired with real numbers. The distance between any 2 points is the absolute value of the difference of the numbers. So, if we're taking the distance between C and E, C is over here at -6, E is over here at 1. You would do -6 minus 1. That would give you -7, and then you take the absolute value, aka what's the positive distance between those numbers, which is 7. Now, I don't want you to get hung up on the absolute value of it all. It's really one main thing. Distance for what we're going to be dealing with is a positive number. Okay. So if I'm talking about from C to E, even though this has negatives and positives on the number line, I'm talking about how far is the space between these. So that's going to be what we're using. Okay. Now, to go with the ruler postulate, we have something that we use to set up our equations. Sorry about that. Our equations are going to be set up using the segment addition postulate. So, what is that? If 3 points, A, B, and C, are collinear and B is in between A and C, then AB plus BC equals AB. Now, the idea with this is that we can use the information that we know about how lines are made so that we can go through and set up an equation. So I have this line here from R to T. Somewhere in between there, there's this point S. I know that this whole line from here to here is 34. The smaller part of the line from R to S is 22. So what is the smaller part over here from S to T? Well, I know that RS plus ST equals RT because those two smaller segments are part of the whole thing. Now, what I can do is I can take that equation, set up the math with the information I have involved, like how RS is 22 and RT is 34, and then I can solve for ST by just going through and getting this by itself, which is subtracting the 22 from both sides, giving us 12. Now, all the segment addition postulate is just a jumping off point for us to go through and set up equations. Okay, keep that in mind. Use the letters that we have on there so that it could build you to the next part. All right. Now, along with the segment addition postulate, we got some other bits of vocab that we got to talk about. So let's talk about the midpoint and the word bisect. So a midpoint is a point on a segment that divides the segment into two congruent parts. So, on this example here, N is the midpoint of the line segment AB. If that's the case, this side here from A to N is congruent to this side here from N to B. That's why we have these two hash marks on here. So, this right here, this is our whole line, and these are two equal parts. Now, just like how a midpoint splits things into two equal parts, the word bisect is the verb that lets us know that we are dividing into two congruent parts. So think of this like the noun version, this is the verb version of it. Okay. So occasionally you'll get a situation where it says N bisects AB. With that information, we can be able to go through and set up any other bits of info concerning this line. Like I know that because N is bisecting that, that means that AN is congruent to NB. I can also say that 2 times AN is equal to the whole line, which is AB. Or I could say 2 times NB equals AB. But basically, I know that those two parts, they're both the same. So really, that number times 2 gives me what AB is. Now, what we're going to do is we're going to use the segment addition postulate and our different vocab words with midpoint and bisect so we can go through and solve this equation. So, in this example, G is the midpoint of RT. They want us to find what RT is. Now, if G is the midpoint of RT, that means this side and this side are both equal. Okay? So, what I can do is I could take my two sides, 4x plus 1 and 2x plus 10, and set them equal to each other to find out what x is. Now, in situations like this, you have to make sure you pay attention to the directions. This does say find what RT is. So, using the information we have from the line, we can find out what x is and then take x and plug it back into our equation. So, I know that both of these two add up to the whole line. So if x is going to be 4.5 when I go through solving it, I plug that back in to this plus this, and that gives me what the whole line segment is, which is 38. Again, I only get that because I know this to this is what I get when we add these two together. And since I know what x is equal to, I can just go through and plug that in there and evaluate it accordingly. No biggie. All right, let's talk about some practice. Okay. You got a couple different points here. You got in the directions, A, B, and C are collinear, and B is in between A and C. It usually does help for you to draw a line. I'll go through and give you a quick one to help you out. Now, keep in mind, this isn't drawing the scale. I'm not saying that one side is this or that. We just have these 3 points, A, B, and C, and they are all collinear. Okay, using that information, you're going to go and find out these different things. For one, you're finding out what AB is if BC is 20 and AC is 36. For two, you're going to find X if AC is 22, AB is X plus 10, BC is X plus 14, and find RT and RS. We're going to be using different sets of points for those. Okay, follow the directions for those when you get to it. Then down on the bottom, we got some practice concerning the coordinate plane. Use the coordinate plane, aka all of these x's and y's, so we can figure out if AB here is congruent to CD, or if this AB is congruent to this CD. Okay? Use the boxes to your advantage, and I will see you in a few. Make sure that you pause it, come back, check your answers. All right. Hopefully you paused the video. So let's talk about what we got going on, people. All right. All right. First off, for number one, oops, sorry about that. For number one, we got AB is what we're trying to find. AB. If BC is 20 and AC is 36. So for this one, AB would be 16. Why is it 16? If I know that the whole line from A to C is 16, not 16, 36. The whole line is 36, and I know from B to C is 20. To find A to B, I would just take that 20 and subtract it from the 36, and that would give me what we are looking for. All right, what about the next one? Next one we got AC is 22, and then we have AB and BC. Now for this, you have to set up an equation. We got 22 is equal to what these two are added together. Now, for the sake of saving space, I'm going to go through and combine my like terms now. I know I got two x's, which makes that 2x. And then I have 10 and 14, which is 24. Now, I'm looking for x, so I'm going to solve this equation for when x is going to work out when it equals 22. When I go through and do that, I end up getting a -1. That's because I ended up having to subtract the 24. That gives me a -2. 2 divided by a -2 is going to give you -1 here. All right. Now for the other one, I got to make sure I pull up the actual notes because I don't have the full information here. So let me go through. Let me go. Where's the notes? Oh, sorry about that, y'all. Okay, so for the second set of points, they say RST are collinear and S is in between R and T. So just like how we did for ABC, we're having RST. So we got R goes over to T, and somewhere in the middle is S. Well, not in the middle, just in between them. Don't harper on the middle. All right. Now, if that's the case, we got all that information here. Let's set it up. We said that we're going to find RT, which is the whole line, if RS is 1.3 and ST is 4.3. So those are the two parts. RS is 1.3, ST is going to be 4.3. So I go through, and since those two are in between these 2 points, I can just add them together. So adding them together means that I have 5.6. Perfect. Now we can use this picture here to set up for the second one. We're going to find x if RS is 8x plus 4, and ST is 4x plus 8, and if the whole line here is 15x minus 9. Now, if that's the case, we got to make sure we set it up, okay? So let's put out a pen. So the whole line is RT, the whole line. So that means that everything equals, sorry about that, y'all. So the whole line here equals that 15x minus 9. Now, if that all equals 15x minus 9, then that means that these two parts, RS and ST, add to give us this. So let's go through, let's combine some like terms. We got 4 and 8, that gives us 812x. Then we got this plus 4 and this plus 8, which just gives us a plus 12. So I go through and start to solve. I got to bring the 9 over to the other side. I got to bring the 12 over to the other side. This is going to turn it from what we have up here to 21 equals 3x. I get 3x because I subtracted the 12x from the 15. I get 21 because I'm adding 9 to the 12. If that's the case, I have to divide both sides now by 3, which means that my x equals 7. So that's what I got. All right. Now, we're using the coordinate plane to see if these lines are congruent. So in order for you to do that, you're going to uncap the boxes that we have going on here as if it's a number line. So remember, the x-axis going from left to right, left side's negative, right side's positive. The y-axis going from up to down. That means that the bottom is negative, top is positive. Let's go through and find those distances. So AB is from -7 to 3. So I subtract those, take the absolute value. That means that this is our distance from A to B, 10. CD is from 1 to -8. So when I subtract those, I get 9. Now, if we're asking if these two are congruent, I'm looking to see if they're the same. Are their distances the same? No, these are not congruent. Okay. AB is bigger than CD. So let's check the next one. Next one, we're going from -5 to 7 for AB. And then I'm going from 2 to -10 for the other one. So I go through, I got 12 for the first one. This should actually be 12 for the second one. I don't know why that didn't pop up. My bad. And then that means that since both of these two are the same, these two lines are congruent. All right, people, I'm going to catch you on the next video. We're talking about measuring angles. See ya then.